This assessment asks us to draw the Lewis structure for the molecule H2CO, a molecule we know as formaldehyde. The video may get a little bit long, so you might want to watch it on double speed playback. We start by figuring out how many total valence electrons we have. Carbon is going to contribute 4, oxygen is going to contribute 6, and each hydrogen is going to contribute 1. Because we have 2 hydrogens then, there are 2 more electrons. Adding those up, 4 plus 6 plus 2, we have a total of 12 valence electrons. Carbon, being the least electronegative atom, is going to be at the center of this Lewis structure, and so we can go ahead and attach it to the oxygen, the hydrogen, and the hydrogen using a 2-electron covalent bond. At this point, we've used a total of 6 valence electrons. Our rules tell us that next we should give electrons to the most electronegative atom, in this case oxygen. We have 6 left. Let's place those. 2, 4, 6. This gives oxygen a filled valence shell. Now, if we were to stop here and calculate the formal charge, we would see that the carbon now has a +1 formal charge, and its octet is not filled. Oxygen has a -1 formal charge, and its octet is filled. Having a Lewis structure without filled octets or with opposite charges is not going to be the most stable Lewis structure, so we can do better. Let's do better by taking one of these lone pairs on the oxygen and moving it down to become a new oxygen-carbon bond. This is a preview of a concept called resonance. What that's going to give us will be this new structure where oxygen now has just 2 lone pairs. It has a carbon-oxygen double bond. We still have our 2 hydrogens here. If we calculate the formal charges for this new structure, we'll see that carbon's formal charge is neutral, oxygen's formal charge is neutral, both hydrogens are neutral. Every atom has a filled valence shell, and so this represents the best Lewis structure for formaldehyde.